Hello everyone. Today my topic is the organic iron speciation in surface transect across a frontal zone, the Chatham Rise, New Zealand. First, I want to talk about algae because the algae grow up all we need that we need nutrients to grow up, but not enough. That's no, because they need iron to grow up. And is these two types of iron? No. The answer is no. Then they need is the iron to combine with the organic ligands. We call LT in the later. And the algae will grow up fast and more. Why we need that? Because the biological pump. The phytoplankton can absorb the carbon dioxide and when transferred to their shell, and when they die, they will take the carbon to the deep ocean, so they can decrease the global warming. So the scientists want that to experience that can work. And the scientists find the HNLC, the high nutrient, low chlorophyll A. We want to know why they have the low chlorophyll A. So scientists wants to know if that is the lack of the iron. So the iron hypothesis will come. The iron hypothesis was to throw the iron sulfate into the sea to see the algae will grow more or faster. And this is our experiment place. We have the subantarctic water, and it's the HNLC's place. And the subtropical water, which is the high temperature and high salinity water. And our want to know areas, the subtropical front. The subtropical front. And what's front? Front means two water mass meets. And when hot water comes and cold water comes, and the front will come. And the front have two types, has hot front and cold front. Hot front means hot water to push the cold water backward. And why we do these experiments? Because the SV water is the HNLC, high nutrient and low chlorophyll A. But at the subtropical front have the high primary production. We want to know why that at the STF can enhance the primary production. That's the method. We collect seawater and hydrographic data, and all of them collect in October 2000. The seawater collected by this equipment is covered by metal free. So not pollute the sample. It has the hose to point forward to keep pump water to the ship laboratory. And we will be 1 to 2 meters deep to collect the surface water, and 6 meters away from the ship to keep the ship pollute the water sample. And the hydrographic data is collected by the CTD is here. And I hope I can convince that the current could be an important vehicle to cause the relative high primary productivity within the SDF, the subtropical front. And here's the hydrographic data. We can see the y-axis is the latitude, and the x-axis is temperature. And in this figure is different. Is the y-axis is temperature and the x-axis is longitude. We can see that in the hot bay, the subtropical water has the high salinity and high temperature of water, and low in the otago, and convergence in the intermediate at the Chatham Rise. And these 2 points have the difference pattern. And this one is because it's near the landmass, so the river cause the lower, little bit low salinity and little bit low temperature. And this point is because the escape current to cause them a little bit high. And the nutrients are all low in Hawke's Bay, the North Station, and Otago is high in the sub-Antarctic water. And we can see the pattern is relative constants, but the highest area is in the SDF. But the silicon is different to other two types of nutrients. He has the 4 points in here to below the detection limits. The other thing is because that the phytoplankton cause that. The phytoplankton use the silicon more, so in this area the silicates were below the detection limits. And so we can see in the chlorophyll A data. This is chlorophyll A data. And the y-axis is the latitude, and x-axis is the concentration of the chlorophyll A. We can see the constants and at these two transects, and these 4 points we just mentioned before. And the iron. In the Hawke's Bay, it decreased in the southeasterly direction because the landmass is there has a river to come from this area, so we will be lower concentration to the easterly direction. And the Chatham Rise has the highest points and decrease on both words. And the highest point is at the escape current. And Otago has a low and relative constants. Here's the LT, the organic ligands. Here's a high and relative constants at Hawke's Bay. And the Chatham Rise, the pattern is like chlorophyll A. So we can suppose that the ligands is associated with the chlorophyll A. And the Otago is relative constant and lower. And that's not enough. We calculate the excess iron ligand concentration. We use the concentration of the organic ligands to minus the concentration of the iron, so we can know how many irons are combined with how many ligands are combined with the iron. So we can see the data here. The lowest place means more iron combined with ligands are in here, the escape current place. And here's my conclusion. We asked why the SDF can enhance the primary production. The others, and I think, is because the current could be an important vehicle to transport the ligands and iron to this place, to cause the relative high primary productivity within the SDF. The escape current transport the ligands and iron to this place to cause to let here have the more ligands and iron to let the algae use. And nutrient have the highest place in here because front is two types of water to mix together, and we will mix together to let the surface water to transfer to the surface water. So the nutrient will be the highest place in here. So the nutrients and iron are high. So the chlorophyll A were high in here. Thank you for listening.